Hello, this is Dr. Oz. In this video, I will be talking about transportation models. And transportation is one of the most important components of a supply chain management system. So the learning objective here is develop an initial solution to a transportation model. And we will use northwest corner and intuitive lowest cost methods. The transportation modeling is a special class of linear programming. And linear program is called linear program because the objective function and the constraints are linear. So in transportation modeling, we need to know the origin points. In other words, the sources and the capacity or supply per period at each node. So we need to know the capacity or the supply. The destinations and the demand per period at each node needs to be known as well. Destinations and the demand needs to be known. And the cost of shipping one unit from each origin to each destination needs to be known as well. Cost of shipping. So let's look at an example. We have 3 cities here, origin nodes, and we have 3 destination nodes here. And you can see the cost between these origins and destinations. We call those arcs. For example, from Evansville to Boston, sending a product will cost us $4. Let's show this on a map. So you can see that these factories show our source nodes or suppliers. And also we see our demand points here, 3 of them. And you can see how many units they demand. And you can see how many units I can supply from each of these locations. Right. So let's look at the transportation matrix. Here on the right-hand side, we have the factory capacities. At Des Moines, I have 100 units of capacity. At Evansville, I have 300 units. In Fort Lauderdale, I have 300 units. These are my capacity constraints. And my total supply is, in this case, 300 plus 300 plus 100, which is 700. And in this case, also, I have demand information from Albuquerque, 300, from Boston, 200, from Cleveland, it's 200 as well. If you add these values up, also, you will get 700 demand from these 3 cities. We also have cost information here. $5 per unit from shipping a product from Des Moines to Albuquerque, $4 to Boston, $3 to Cleveland. From Evansville to Albuquerque, it will cost me $8 per unit. It will cost me $4 to Boston. It will cost me $3 to Cleveland. From Fort Lauderdale to Albuquerque, it cost me $9 per unit, $7 to Boston, and $5 to Cleveland. So these are the cost information here that I have. And then I will put the flow information here. These are my decision variables. Since this is a 3x3 matrix, I have 9 decision variables. Basically, I'm trying to decide how many units should I ship from what supplier to what customer. The first approach I would like to discuss here is called northwest corner rule. And we start with left-hand cell or northwest corner on the table, and then we exhaust supply or demand for that row or column. And then we cross that row or column out, and then we will move on from northwest to southeast. So these are the steps for this problem. Let's do one by one together here. So I will start with northwest corner right here from D to A, and I can send 100 from Des Moines maximum, and I can receive maximum 300 to Albuquerque. So minimum of 100 and 300 will give me this value right here, which is 100. So if I send from D to A 100, basically I cross out the row. So I don't have any capacity anymore in Des Moines. So now I look at this spot right here, my northwest corner, and from E to A, I can send up to 200 units. That will cross out my column. Now I will look at this spot right here from E to B, and I'm only sending 200 from E, so I have 100 capacity left here, so I can send 100 units here. If I send 100, that will cross out the row, and I will have the demand need here for 100 units. And now my northwest corner is right here. I can send 100 units from F to B. That will cross out my column. And then I will have remaining 200 from F to C that will cross out my row and column. So I'm done. My solution here is send 100 units from D to A, 200 from E to A, 100 from E to B, and 100 from F to B, and finally 200 from F to C. So if I put this information in a table, I'm sending products again from D to A, 100 tubs. I send E to A, this is 100, 200 units. From E to B, I'm sending 100 units. From F to B, I send 100 units. From F to C, I send 200 units. And the costs are $5 per unit, $8 per unit, $4 per unit, $7 per unit, and $5 per unit. And if I multiply this, 100 times 5 will give me $500. 200 times 8 will give me $1,600. 100 times 4 will give me $400. 100 times 7 will give me $700. 200 times 5 will give me $1,000. If I add these costs up, I will get $4,200 of total cost. This is a feasible solution, so which means that this is a possible solution, but not necessarily the lowest or optimal or the best solution. I cannot say that this is the best, but I can say this is a feasible solution. All right, so we are done with northwest corner approach. Now let's look at the next approach, which is intuitive lowest cost method. And this is another easy way to solve this problem. Basically, I identify the cell with the lowest cost, and I look at as many units as possible, and I find again the lowest cost from remaining possibilities, and then I will keep repeating step 2 and 3. So let's do it on the same example. So the lowest cost here, as you see, is $3. I have 2 of them. You can pick either one. Let's choose D to C. So here I can maximum send 100 units that will cross out my my row. So I cannot send anything else from D, and I have 100 units needed at C now. My next lowest one is this 3. So here I can send 100, which will cross out my column. Excuse me. And I have now 200 capacity at E left. So I'm looking at this lowest cost now between 8, 4, 9, and 7. 4 is the cheapest here. And here I can send maximum 200 units that will cross out my row, that will cross out my column as well. So I cannot send anything from E anymore, and I'm not gonna send anything to B. So I will have 300 units left here that will cross out my row and column. So this is my solution right here. 300 from F to A, 200 from E to B, 100 from E to C, 100 from D to C. Right? So that's the intuitive cost method. And if you make the calculations here, you will get 100 times $3 plus 100 times $3 again, plus 200 times $4, plus 300 times $9. And if you do the math, 2,700, 800 more, 3,500, 300 more, 3,800, and 300 more, 4,100, which is cheaper than our previous approach. But again, we cannot say this is the best solution. That's it for today. And until next video, enjoy supply chain management.